Hello, I'd like to introduce you to the MiniTrol. This is one of our versatile economical instruments. It's a rate totalizer for pulse-producing flow meters, and it's shown here in the low-cost enclosure we designate LCN4X. This is a 6-digit LED display on this rate totalizer. It can operate with either contact closures or voltage pulse inputs. It has a view button that allows you to display the rate, the total, or an auxiliary total. Outputs include 2 Form C relays as standard. Optional features include a 4 to 20 milliamp output or an RS-485 Modbus RTU communication card. I'd like to now review with you the button operation in the operating mode. You'll notice initially that the display has an R in the far left-hand side as well as a numerical value. This is showing you the flow rate. To view the other indications on this device, you press the view button. The first item is showing you the total on the A channel. The second, where all the decimal points are lit, is showing you the total on the B channel. Pressing the view button again returns the display to showing you the rate. There are 2 alarm points on this, and the alarm points themselves can be shown by pressing the keys labeled either pre-A or pre-B. Let's look at the set point for the A alarm. First, it'll show you the value as a pre-A, and then the number immediately changes to show you the alarm point. Similarly, if we press the pre-B button, it'll show us the value on the pre-B. Pressing enter or any other key returns us the display of the rate. Now you'll notice if I attempt to enter the program button, the display warns me that the unit is currently locked by password. Similarly, if while displaying the rate I attempt to reset it, it'll inform me that the unit is currently locked. One of our other buttons, therefore, is actually the unlock button and lock button. This works as a toggle. If the unit is currently locked, it'll unlock the unit. If it's currently unlocked, it'll lock the unit. So let's look at the operation to lock and unlock the unit. Pressing lock button, there'll be a prompt for code. In this case, I've set the internal password to 1000. So I have to enter that number using the keys underneath each digit until I obtain the necessary code, then press enter. You'll notice the unit responds to a proper password by telling me it is now unlocked. At this point, if I wanted to change the presets, let's say from the alarm being at 100 to some other value, I can do that by pressing a key and changing the alarm point. Again, you can only change the alarms while the unit is unlocked. Now, the next operation we may want to consider is how to change the operating mode to configure the instrument. This is done using the program button. Now, since the unit is currently unlocked, we're going to go to that sequence. I would like you to follow along by finding page 7 in your user manual. Here, you'll notice that there's a flow chart of the basic configuration of the instrument. It begins with a statement where it says start here, and you'll notice that there's small symbols indicating the key to depress to move into the various menus. You'll notice first that pressing the program button brings you to the first menu group, which in this case is for the group called Factor. Pressing the program button again moves you to the next menu group, and so on. Once you're at a particular menu group of interest, pressing the Enter button brings you into that group. Finally, when you complete a group, it returns to the Run mode. Often, it's advisable before entering into the setup mode to display the flow rate, because then you'll have the indication of an R in the far left-hand side to tell you've returned to the Run mode. We'll be entering each menu group, configuring it, and then returning to the Run mode before moving in again to the next menu group. Now, before we begin, I want to introduce to you the concept of flow meter KFactor. The flow meter KFactor is basically the calibration constant for pulse-producing flow meters. This value is often provided on a measurement certificate that accompanies each sensor, but it may also be actually stamped on the body of the flow meter or on a metal tag affixed to it. And it's normally expressed as a number, in this case 100 pulses per gallon. Now what that means is that that flow sensor produces 100 pulses for every gallon passing through it. If you wanted to have a resolution that is in 10th gallons or 100th of gallons, it's important to realize that 100 pulses per gallon could also be stated as 10 pulses per 1/10th gallon or 1 pulse per 100th gallon. This is important to begin your setup of the instrument to know what is the actual calibration for your sensor, as well as the flow range that it can measure over, and to know what the units that you desire to display on your indicator for the rate and the total. I would like you to follow along on the menu again on page 7 as we now go through the basic configuration of this instrument under the assumption that we want to read in gallons per minute and whole gallons on the display. We begin with an unlocked unit by pressing the program button. The unit responds to the first key depression by displaying a message that it's at the point where it's going to show you the factor group. By pressing Enter, it goes to the first menu. These abbreviations on the display are meant to provide a prompt for you. In this case, it's showing the decimal point that's going to be used for the factor for the A channel. And I'm going to be entering this with a resolution down to tenths of gallons on my KFactor. So therefore I'm going to choose a decimal point position that will give me that amount of resolution. After pressing this, I can now go through and enter my 100 pulses per gallon KFactor with a resolution of 4 digits for this example. Once I have the desired number appearing, I can hit Enter to move to the next channel. In this case, since this is a 2-channel instrument and there is an auxiliary totalizer, I'm going to enter the same calibration constant in the B factor to the same resolution. So once again, I'm going to show 1 digit, and by pressing Enter, I'm going to enter the same calibration constant in the second channel. After that's displayed, I'm going to hit Enter, and at this point it's going to return me to the run mode. Now you may remember, in the run mode you can see several totals as well as the flow rate. And I'm going to leave this displaying the rate so we know each time we return to the run mode. So let's go to the second menu group now by pressing the program button twice until I'm at the count submenu group. I'm now going to hit Enter to go into that submenu group, and my first selection here says RST0, and this is how the instrument will respond when the reset button is hit. It'll reset the total to 0. This corresponds to a mode where the totalizer will begin at 0 and count up from that point. This is the most common in a totalizer application. I'm then going to go to where it's offering me a selection for the decimal point location to display when it displays the total. I wish to display in whole gallons, so therefore I'm going to have no decimal points illuminated. Hitting Enter again, it now is telling me the mode of operation for this instrument. In this case, it's saying that it wants the A and B channels to be separated. So it's saying A separate B. This is the most common channel for this instrument, or most common mode for this instrument. The final menu in this group informs the unit whether this is going to be a high-speed pulse or a contact closure input. In this case, high counts per second is indicating the unit is going to be used with an electronic pulse output. The alternative selection, which can be obtained or viewed by pushing the program button, is low CPS, or low count speed. This is what would typically be used with a contact closure input. We're going to assume that the instrument is going to be receiving a voltage pulse and needs the high count speed. To finalize that selection, I hit Enter. At this point, the unit returns to the run mode and displays the flow rate for me. Let's go to the next menu group, which is associated with the rate. Pressing the program button several times brings us to the rate submenu group. Pressing Enter brings us into that menu. Now the first menu has a selection on it that let me either display the rate in rate per second or select scale, where the instrument will permit me to choose a scaling constant. I'm going to hit Enter with scale, and this symbol with the 60 indicates that I want to read in rate per minute. That's the selection we wish to use on this application, so I'm going to hit Enter. This next menu, normalization, is an averaging constant. This may be used once the system is online if pulsations and flow are observed that are objectionable to the rate display. Increasing the number entered here provides additional averaging. We're going to start out with no averaging in this instrument. The next menu lists the number of significant figures. This is another means of reducing the dampening effects on the rate display. This unit has an auto decimal point location when it displays flow rate, or an auto ranging, and this display tells how many significant digits to show of that rate display. The most significance is obtained with a significant figure of 5. Significant figure of 1 would correspond to the least significant, and the numbers therefore would jump by very large amounts. Settings of 4 or 5 are commonly used. I'm going to choose 4 in this application and finalize that selection by hitting the Enter button. The delay menu is used if you're encountering very slow pulse rates that you want to indicate on your flow rate display. In this case, a delay of 2 means the rate display will wait up to 2 seconds for a pulse before determining that the flow rate has gone to 0. Increasing this number allows the instrument to wait longer and longer periods of time for a pulse to appear. Smaller numbers indicate a smaller time. This is typically used with contact closure inputs that have slow repetition rates at low flow to advise the instrument to wait a longer period before assuming that the flow rate is 0. I'm going to leave it with the default setting of 2 seconds. That completed the setup of the rate submenu group, and the unit returned to the run mode. Let's go to the next menu location. Again, pressing the program button until you see lock, which has the parameters associated with the lockout codes. Hitting enter here, you can see that the unit can either permit you to lock out all parameters, and lock all will block access to the set points or to clearing of totals, or the alternate selection is just to lock the program. This would still allow you to block people from accessing the setup mode while allowing them to change either set points or clear totals. We're going to assume lock all, since this is the most common one required in real applications. The next menu allows you to define your password. You'll notice here that I've assigned a code of 1000, and this is where I'm defining the password that will later be needed to lock or unlock the unit. Since I'm satisfied with that number, I'm going to hit enter, and the unit will again complete that submenu group and return to the run mode. There's one further menu in this instrument, and this is associated with the relays. In our application, I'm going to set the relays to function as high and low flow rate alarms. There are 2 relays, so we'll be asked questions on 2 separate relays. So let's go into that submenu group by pressing enter. The first relay, indicated by the A, is currently assigned to rate. There are other modes of operation, and these are to assign it to total. In our application, we want to use it as a rate alarm, so we're going to leave this assigned to rate. Unfortunately, I had pressed the button too quickly and moved out of that menu group prematurely. I'm just going to go back into that mode so I can show you the B relay. This is similar in the sense that it again has selections of either total or rate. In some instances, you may wish to use the second totalizer as a low-speed scaled pulse output. The other modes are to assign it to rate, and that's what we're going to do in this application. We're back now in the run mode. Let's assign these 2 alarms, the first to 10 gallons a minute and the other to 90 gallons a minute. To change the alarm on rate A, I will press pre-A and then go through and change the digits one by one until I observe 10 on the display. Once I'm satisfied with the settings, I can press enter. I'll now go through and change the second alarm point to 90. Once I have a satisfactory display appearance, I can hit enter. At this point, we can lock the unit and the setup is complete. We had predefined a password of 1000, so I'm entering that number and then pressing enter. The unit responds that it is now locked. This completes the basic setup of the MiniTrol, and the unit can now be put into service. If you have questions about any of our instruments, you can feel free to contact KEP, or you may find additional information at www.kep.com. Thank you very much.